Thank you. So, for the past couple of years, it's become sort of obvious that drones can actually contribute in a positive way to the healthcare sector. We have seen different projects throughout the world where drones have been used to deliver medicals to out-of-hospital incidents. We have seen drones being used for deliver medical samples or blood between hospitals. And this is a sector where Everdrone want to be in. I'm going to use my minutes here today to talk about the challenges we need to overcome to make these concepts a reality. And first and foremost, Everdrone develops software and sensor technology. We're not a hardware company. Software is what we know, and software is what we do. And we're doing this with ambition to enable safe drone operations with a very high level of autonomy. The system and the technology we're developing can be integrated with any drone platform, and this basically means two things. To start with, it means that the end user can pick and choose a platform that is suitable for their application in regard to size and payload and so on. And we can integrate our system with that platform. Secondly, it means that it allows us to scale in the future when we can start applying our platform horizontally in the drone industry as well. Until today, we have performed more than 11,000 real-world autonomous drone operations, both in lab environment and in real outdoor environments. Simulation is a very crucial part of our work, and we have performed more than 900,000 simulated flights to date. And we're the first company in Sweden doing BVLOS operations, that is beyond visual line of sight operations with machines that are controlled and monitored over the mobile network. And we did an interesting operation a few months ago together with Sahlgrenska, where we did a demonstration to transport blood samples between Guldheden, Sahlgrenska Hospital, and Mölndals sjukhus. And it looked like this. So this operation was interesting for a number of different reasons. It's not only combining the two most difficult things from a regulatory perspective, that is flying beyond visual line of sight from the operator and also flying in a populated environment. It is also 100% autonomous. And this is something I'm always nagging about, the difference between autonomous systems and automated system. If you have an automated system, it can perform the same task over and over again very precisely, and that's great. But what we're developing is an autonomous system that is able to make intelligent decisions in an unstructured environment. So that's really the key challenge that we set out to solve when we started the company. And for a system or a vehicle to start acting autonomously, we need to provide it with a sense of awareness. We need to provide it with a very good understanding of its surrounding. And we have done this by combining cameras, stereo vision cameras, and putting them all around the drone that we saw in the film. So the drone is able to sense and avoid all sorts of obstacles in its surrounding, and by doing that we can start talking about an autonomous system. Combining all this data and visualizing it looks like this. So as you see, the drone has a very high fidelity understanding, 360 degrees, 3 dimensions understanding of its surrounding, which it uses to navigate in a precise and safe manner in all situations. This sense and avoid system, camera-based sense and avoid system, is unique in itself, but it's just one of a number of different key features that we have in our flight system. So I don't have the time to go into detail from a technical perspective, but the important thing here is that you have a large number of systems that are combined with operational procedures, maintenance procedures, training procedures, and so on. And all together, we're getting a system that can be represented by the Swiss cheese model. So it basically means that each slice of the cheese is representing a technology, a feature, a safety logic, a fail-safe system, or even a human procedure. And none of these systems are perfect. All these slices of cheese has holes in them, and a hazard or a danger might be able to penetrate one or two or more of these systems, but in the end of the day, we must have enough of these systems stacked up to create a solid piece of cheese, so we're avoiding a catastrophic failure. And why is this important? It's important because we are operating in the aviation sector, and the aviation sector is one of the safest industries we have. There's very, very little risk involved in stepping on an airplane. There's much greater risk getting in your car in the morning than getting on a plane. So what we're really trying to achieve here is to meet the acceptable level of risk that we're talking about in the drone and in the aviation industry. And in the aviation industry, what's considered acceptable is to have 10 to the minus 6 or even down to 10 to the minus 9 incidents per flight hour resulting in the death of a person. So that is 1 incident per 1 million or 1 billion flight hours. And that's quite a challenge. And this is sort of summarizing what we are doing, the level of safety we need to reach, and the way we need to do it, because what we have is machines that are fairly cheap from an aviation perspective. They are not type certified, as you would normally have in the aviation industry, and they are also unmanned. So reaching an aviation level of safety using fairly basic machines through all these different layers of safety systems, that is the overall challenge of the drone industry and what everyone is working with. And we have come a long way. We have quite a way to go as well, but we're very positive toward the future. And you can read more about our technology on the website, and we're outside in the exhibition area. Please come and talk to us. Thank you.